Welcome. So, please note that the recording is on. All right. So, this morning we're going to start from where we left last week. That is chapter 8. And I'm also sorry if you guys cannot hear my voice properly because I'm having some flu, but I will be okay. Right. So, we're going to get into it straight away. So what is going to happen, I'm going to share my screen so that you can see everything that I'll be doing. And if you have any questions or you want to comment on anything, you can just unmute yourself and then you interrupt me. Because if you raise up your hand while I'm sharing my screen, probably I won't be able to see. And you can also still use the chat box. When I'm done, I can look at the messages and respond to them accordingly. All right, so I believe that you guys can hear me. So let me share my screen. All right. Okay, so we spoke about the key success factors. We also cover the first model of analysis in terms of a company choosing a new location for its activities. So today we agreed last week that we're going to talk about the break-even analysis. So what is the break-even analysis? So it's what is it? I think it's here. Yeah. Yeah. So it's a method of cost volume analysis used for industrial locations. So here we're mainly focusing on industries that are willing to change or open their branches in new territory or a new location. So the three steps that are followed in terms of coming up with a break-even analysis, there are three. So the first one is to determine the fixed and variable cost for each location. So this is critical when it comes to doing a break-even analysis. So first of all, we have to identify as a business the fixed cost, and you also have to identify the variable cost. For you to identify this, you need to know the difference between a fixed cost and a variable cost. Otherwise, you're going to mix up everything, and at the end of the day, your analysis will not be accurate, and that is a very big problem for a business. So you can define variable cost or fixed cost from a different perspective. But generally speaking, a variable cost is a cost that changes as the volume changes. So the more product are bought, the more the variable cost also tend to change. And one of the examples that we can put forward in terms of us understanding or putting this into practicality is that raw materials are considered as one of the variable cost, or you also have production suppliers, can also be referring to delivering cost, right? For instance, credit card fees are also considered as variable cost, right? As I said, so variable cost are costs that change as the volume changes. So on the other side, you have um, fixed cost. So what are fixed costs all about? So fixed costs tend to be costs that are based on the time, and rather than quantity produced or sold by a business, right? So there is a time frame for fixed costs to be dealt with or to express themselves, unlike the variable costs that change according to the volume of production. Right. So, in terms of the fixed cost, one of the examples that we can put forward could be rent, your rent that you pay. And now we are talking about the industrial locations. So we're talking about probably a company renting a plant, and the payment is done on a monthly basis, right? Or the lease costs that are related to the plant, things like that. So in the service sector, you might talk about the loan repayment, for instance, in terms of the mortgage that need to be paid every month. So this is just to put it in perspective, what are the possible costs, right, that are found or are considered when it comes to deploying or undertaking a break-even analysis. So costs are critical for a break-even analysis, and you have to be able to differentiate a fixed cost from a variable cost. Now, number two says plot the cost for each location. So this is a graphical analysis that need to be done so that everything can be seen clearly. So we need to plot a graph in order to the graph to see all the cost, or we call them the cost lines. And number three, select the location with the lowest total cost for expected production volume. So again, at the end of the day, is the objective is for a company to minimize the total cost, right? Because once the company is able to keep its cost or its total cost low, the probability for the company to make money or to have profit margins is quite high. So that's why number three says select a location with lowest total cost for expected production volume. So let's look at this example here. So in this example here, we have three locations. So from the three locations, let me see if I can grab my pointer here. Yes, from the three locations, each location has its fixed cost and its variable cost, as well as the total cost. But the total cost in this case is given by the expected volume. So for you as a business to find the total cost, you need at least to speculate on the number of units that the company is planning to produce at that specific location. So from this example here, we have three locations. So you have Akron, Bowling Green, and Chicago. It was even better to put South African location so that we can best relate to the example, but anyway, it's not a big deal. So the first city here is Akron, or the first location, and then you have Bowling Green, and then you have Chicago. Right, so let's look at Akron, for instance. You have under fixed cost, you have 30,000, let's just call it rand instead of dollars. So here we have fixed cost of 30,000 rand and a variable cost of 75 rand. So here you have a total cost of 180,000. So this total cost, you can only get it by considering the expected volume of 2,000 units. Right. So here you also have Bowling Green with its fixed and variable cost, including the total cost. Again, the total cost is given by using the 2,000, but I will show you how to use it. It's an equation that need to be solved in order to come up with the total cost. Chicago, you also have the fixed cost, the variable cost, and the total cost. Now, from this example here, below we have the total cost equation. So for you to find the total cost, you have to have the fixed cost, right, plus the variable cost times the volume. So remember in the going back here, share from the steps, it say determine the fixed cost, variable cost. So once these costs are known, now you plot the cost for each location. So in other words, a graph has to follow. So this is from that example, I'm going to demonstrate how to come up with certain values here in order to plot this graph. So from this example here, you have this graph. So this graph is just coming from the that table, that previous table that I showed you with Akron, Bowling Green, and Chicago. So from this graph here, now you are able to analyze, to tell which location is the best based on the volume that the company is expecting to produce. But how do you come up with this graph? That is the question that you have to ask ourselves. How do you plot this graph? Because you need certain values in order to plot the graph. So first thing first, let me exit this. Okay, now come out. Yeah. So we're going to determine the critical values, right, that we will need in order to understand how to plot that graph. So what is going to happen here? I open a document here already. So this is the same example. So in order for you to plot this graph, something that you have to do first is to have the equation of each location. The idea is for us to calculate what you call the crossover point. Those values are now going to help us to plot the graph. So how do you go about doing that? So let me just try to zoom it in a bit. So how do you go about doing that? So here we have Akron, Bowling Green, and Chicago. So let's formulate the equation for each location or for each city. All right, so here we are going to have Akron, the equation for Akron according to the total cost formula, right, or function. You're going to have how do you call it? Fixed cost, because it's here already. So fixed cost plus the variable cost. So in this case here, we're going to have Akron. Akron, and the equation for Akron is you have a fixed cost. Fixed cost here is 30,000. So 30,000 plus the variable cost. So the variable cost here is 75. So 75x, it has to be multiplied by the volume because we don't know the volume. So we have to write x, generally speaking, even if there is 2000 unit that is given, but this is the general formulation of the equation. So Bowling Green,
Sir.
Bowling Green, the equation of Bowling
Sir.
Green.
Hello.
Yes, yes.
I'm confused. So we take the fixed cost, right, which is 30 rand,
Uh-huh.
30,000
1,000 rand.
rand,
Uh-huh.
and then you what do? You add 7 or 75.
Sorry, yeah, that is 75.
Oh, okay.
Is that
Thank you.
fine, huh?
Yeah, I was
Yeah.
confused by that.
Yeah, thank you. Yeah, it's 75 instead of 7. Thank you. Yeah. So, yeah, you take the, because I'm following, or we have to follow this formula here. So fixed plus variable cost every time. So here now, if you move on to Bowling Green, is 60,000. So here we have 60,000 plus 45 x, which is the volume. And the last locations equation will be Chicago. So that is 100. Let me just write Chicago first. What's going on? Chicago. And that is going to be 110,000 plus 25x. Right? X is the volume. So now we have the equations, right? The equations that we need. Now we need to now move on to a stage where we check the point where each equation will meet with other equation. That's what you call crossover point. And crossover point here, if you come back to um, this graph here, you will see that Bowling Green and Akron, the cross or their crossover point is right here. And Chicago and Akron, their crossover is here. And Bowling Green and Chicago, they also meet right here. So we are looking for this point here in order for us to explain how to plot this graph. So we have the equations. So the next thing that we're going to do now, we're going to calculate the break-even point or crossover point. So what is going to happen here? You're gonna look for, let's say, you have Akron. We're gonna look for a crossover point between Akron. I don't know, you call it Akron or Akron. I don't know. Akron between Akron and Bowling Green. So we do the matching there. You can also start with Akron and Chicago or Bowling Green and Chicago. It doesn't matter. So you have Bowling Green and Akron. So what is going to happen here? Let me use another line. So we basically going to use the equation. So we're going to say the Akron equation is equal to Bowling Green equation. That is basically what we are going to do because they are meeting at a specific point. So by doing this, we are calculating that point. Now, here you already have an equation that you need to solve for x because x is the unknown value here or variable. So what is going to happen here? Just need to solve for x. Let's just do this one slowly so that the next one will be just putting the values. So here, if you are solving the equation, you're going to have 75x 45x will come this side, so minus 45x, and it's equal to 60,000. 60,000 and 30,000 will go the other side. So that is going to be 30,000. And that is going to give us what? 75 minus 45. Is it 30? Anyway, let's not bother ourselves. 75 minus 45. So that's 30. Yeah. So that's 30. Let me just reduce the size of the line spacing, or let me just remove it completely. Beautiful. So that is 30x, the equal sign, and 60,000 minus 30,000, that is 30,000. So here you're going to divide both side by 30 so that you can be having x only. So 30,000 divided by 30, that is going to give us 1,000. 1,000. So this 1,000 here is what you call the unit. So here, let's say unit, because the unit or the product that are being produced not really disclosed, but they say unit. So here we have the unit. So what you guys also need to understand is that when you are calculating the crossover point, the first crossover point that you are calculating based on the equation, that first one is in unit, is the volume, right? The volume. Now, once you find this one, remember on this graph here, we have the x-axis and the y-axis. So the volume is on the x-axis, and on the y here, we have the cost. So the corresponding cost. So here we have already calculated the volume on the x-axis. But what will be the cost of producing 1,000 units? So how do you find that cost? Because you know that this volume here is given by equalizing these two equations. Therefore, if you take this volume here and substitute x with 1,000, in either, if you choose the first equation or the second one, it doesn't matter. You're still going to get the same value or the same cost. So in this case here, we have 1,000 unit, and we're going to consider one of the equations here. So let's consider this first one. In order for us to calculate the cost of producing 1,000 units. So we're going to consider this equation here. The first one, you can also consider the second one. It doesn't matter. You're still going to get the same thing. So here, now it's going to be times 1,000. To be safe, you can put your bracket there in your calculator. And this is going to give us the cost of producing 1,000 units. In other words, the corresponding cost of producing 1,000 units. So here, if you take 75 multiplied by 1,000, that is going to give us 75,000. Yeah, 1,000 multiplied by 75 is going to give us 75,000. So 75,000 plus 30,000. So 75,000 plus 30,000. So that's 105,000. So 105,000. So this one here is the cost of producing 1,000 units. The company is going to spend this amount. Now, that is the break-even point between Akron and Bowling Green. So let's move on to the next one. The next one is going to be Akron and Chicago. In other words, you are just finding the possible combinations here. So here, it's Akron. This is Chicago, because you have already dealt with Bowling Green, right? So here, Akron equation is 30,000 plus 75x is equal to Chicago. Just pick the Chicago's equation, and this is the one. So you just need to solve for x. Okay, please, you guys also can double check this on your side, because I'm going to go up with this straight to the point. So we're gonna have 75 minus 25, that is 50. 50. And okay, let's say 50x. And on the other side, you're going to have 110,000 minus 30,000. 110,000 minus 30,000. That is 80. So in other words, we're going to have 80,000 divided by 50. And I remove this 50 here. Divided by 50. Guys, if you don't understand, feel free to let me know. And that gives us a value of x equals to 1,600 unit. Again, when you are coming from here, you talking about the product. Now, what is the cost of producing 1,600? Again, from here, you just choose one of the equations. So usually you just choose the one that is simple in terms of doing the calculations. So we're gonna go with this one here. And we replace x with 1,600. 1,600. And that gives us a value of, so that is 75,000, 75,000. Oh, sorry, 75 multiplied by 1,600 plus 30,000. That is 150,000. So 150,000 rand. So this is now the cost of producing 1,600. Now, the other combination that we can come up with is now Bowling Green and Chicago. Bowling Green and Chicago. So here we're going to have Bowling Green, and this is Chicago. Okay. Let me also duplicate the same format. Right. So boiling green equation is here. Just copy and paste, and equalized with the Chicago's equation. And again, you solve for x. What will be the value of x here? Okay, let me just do the calculations from here. Straightforward. So that is going to be 45 minus 25 is 15. All right, so that is 20. 45 minus 25 is 20. So we're going to have 110,000 minus 60,000 minus 60,000 divided by 20. Remember, 45 minus 25 is 20. 2,500. So that is the value of the volume here, 2,500 units. Now, what is the cost at this point? So again, you choose the equation that you feel more comfortable in terms of doing the calculations. Let's go with this one. So we replace x with 2,500. 2,500, and that is going to give us what? Times 45 plus 60,000. That gives us 172,500 rand. So this is the crossover point, or the point at which Bowling Green and Chicago coastlines will meet. And this is also the cost at that point. So now, once you have these values here, you can now proceed with plotting the graph. So I just needed to calculate these values so that we can see how the graph is, or understand how the graph is plotted. So you can see here, how do you call this? You guys know that in order for you to plot a line, right? To plot a line, you need at least 2 points where the line is going to pass through. You need at least 2 points. So from here, if you have to plot the coastline of Akron, for instance, we have the fixed cost. So the fixed cost does not change. That is, it's fixed. So meaning that this is the first point that you have to consider when you are plotting the graph, or you are plotting the graph of a specific line or coastline. So the fixed cost will be the starting point. Now the second point will be now the crossover point where that line will meet with other lines. Now, from the calculations that we did here, we have Akron and Bowling Green. So you know that Akron is going to use 1,000, almost going to pass through 1,000 unit and 1,000 and 105,000. So in other words, coming back to the graph here, before even we reach here, obviously you have to, have the scale, and the scale here depends on you. What you just need to make sure is that all the values, because here you are dealing with big numbers. So you just need to ensure that the numbers, or the big numbers that you have, are also visible on the graph. So in terms of taking your scales, you just need to be careful with that. So, but you can go with any scale. We usually say that the bigger the better. So in this case here, in these examples, they go with on this side, on the y-axis, the scale here is 10,000, 10,000, 10,000, 10,000, up to 180,000. The reason for doing this is that since you are dealing with big numbers, you see when we calculated this cost here, it's 172,500. That is a big number. And looking at the scale here, 172,000 will be somewhere here visible. So what you need to do is that you make sure that the scale that you are taking is going to contain all the values that you probably need to write on the scale. So here on the axis, they decided to go with 500. You could have even taken probably 200 or 400, right? So here they decided to go 500, 500, 500, 500. So that is the scale. And so by doing so, you already have the scale here. And I said for you to plot a line, you need at least 2 points. You need at least 2 points. So in our case here, we already have the 2 points. Akron, you see the fixed cost here is 30,000. So meaning that is your starting point. You see where the 30,000 rand is. So that's your starting point for Akron. Now, the second point is now what we is from the calculations that we did. We said that, we found that Akron meet with Boiling Green at the volume is 1,000, and on the other side you have the cost at that point. Let me see. You have a volume of 1,000 and you have a cost of 105,000 rand. So coming to the what do you call it? The graph here. What you do is that you look at the x-axis, you identify where the 1,000 unit is, that 1,000 unit is. Now you draw a line going up, right? Probably using your ruler, but this usually don't do this manually. You can even do this using an open software or platform online and then plot this graph. So you draw a line going up where the volume is, going up, up, up. You on the other side, now you also, we calculated and then we said the volume, this volume, for the company to produce this number of unit, it has to spend 105,000 rand. So on the other side here, we also identify 105,000 rand, and that should be somewhere here. So again, you also draw a line going this way, and where this line is going to meet this line, that is the crossover point between Bowling Green and Akron. You know that they are going to meet at that point. So again, you draw a line 1,000 unit going up, and you draw another line on this side for 105,000 rand going this way, so that they will meet somewhere here, and that will be the second point that you are going to use in order to draw the coastline of Akron. So you just go up and it will pass through this line upward. So it goes up. Now, once you have plotted Akron here, you also have to do the same for Boiling Green. So let's just quickly also explain Boiling Green. So looking at this table here, the starting point of the Boiling Green line is 60,000 rand. So that is the starting point. So meaning you see 60,000 around this, yeah? So this is the starting point. Now, the second point, remember from our calculations here is Bowling Green and Akron. So meaning that this crossover point here, you can already see on the graph where Akron is passing through is also the same point that Bowling Green also going to use or is going to pass through. Now, you have 60,000, the starting point. So you just draw a line passing over this line and going up there, right? So we have already plotted this one. Now let's move on to the next crossover point. So based on our calculations here, the next one was Akron and Chicago. And this gives us or gave us 1,600 unit. And the cost at that point is 150,000. So again, if you come to the graph here, you identify where 1,600 is. 1,600 should be somewhere here. 1,600 unit. So again, you draw a line going up. And on the other side here, you check where 150,000, that is the cost at that point. So 150,000 is 150,000. So you just draw that one coming here. And where they are going to meet, that will be now the crossover point or the break-even point between Chicago cost line and Akron. And that should be around this point here. Right, so once you have this point, the only line that you haven't drawn so far is Chicago. So Chicago, you also check the fixed cost, and that fixed cost will be your starting point. So looking at the table here, the starting point for Chicago is 110,000. So 110,000 is here. And you know that line must pass through this point here. So that is going to pass through here. And then now you have the equation for the cost line for Chicago. So that is basically how you proceed with it. Even Chicago and Bowling Green, if everything is done appropriately, they will be automatically meeting here. And even if you do the calculations, you'll find out that, remember, we have already calculated 2,500. We'll find that amount somewhere here. Yeah, this was Bowling Green and Chicago, 2,500. And the cost is 172,500. So automatically, it gives you that point there. I mean, graphically, of course. So you have it here, but you have also determined that point using the calculations. So that is basically what you do in terms of plotting the graph. But in our test, you're not going to plot the graph. I'm just showing you guys so that you understand how this thing works. Because even if we're not going to plot the graph, but there are some questions or questions will come in a way by you can use the mathematical approach, right? Do these calculations in order to determine the crossover points, the ranges, but I will show you how to do that. So this is just to determine the crossover point in order for you to plot the graph, to plot the lines, and then you analyze the how do you call it, the different costs. So here we have the graph. You have the different cost lines and all that. Now, what is going to happen here is you have this crossover point, you have these lines. So what is going to happen here is that you need to check, because the objective is to identify the location with the lowest cost. So now, if we check carefully here, from 0 to 1,000, within this range, because this is not the graphical interpretation, you have to interpret the graph. So between 0 and 1,000, the location that provides the lowest cost is the Akron location, or the city of Akron. Why? Because if you take any values here within this range here, within 0 and 1,000, obviously greater than 0, between 0 and 1,000, all the volumes falling within this range here, Akron will be the best location. Why? Because let's say you take a 600 unit, for instance. 600 unit, that is a number here. So you just draw a line going up. The first line, or the first cost line, that line coming from below here going up is going to meet is Akron. Even if you take, let's say, 5 or 50, you are going up here, the first line that line coming from 50 years going to meet is Akron. So within this range here, between 0 and 1,000, Akron has the lowest cost. So the company should choose this location here in terms of establishing its new plant for production. So moving along to the next range, because this is also another crossover point, 2,500. So within 1,000 and 2,500, this line here, which represents Boiling Green coastline, has the lowest cost. Why? Because if you take any values here, right, any values within this range here, and you draw a line, it's like a projection. You project that lines using going up here, or you draw that line going up. The first line that line coming below here, coming from this side here, is going to meet is this blue line, which is the Boiling Green one. So that's why we say from 1,000 to 2,500, Boiling Green has the lowest cost. That is the optimal location. Now, going from 2,000 unit upwards or greater than 2,500 unit, you can also check here. You can see these red lines here will be the lowest location. So Chicago, which is Chicago. So Chicago has the lowest cost, or is the optimal location for a volume greater than 2,500. Even if the company decides to produce 5,000, 10,000, Chicago is still going to be the optimal location. All right. So that's how you interpret the graph, because the idea is to find the location or the range that has the lowest cost. So you can see from here, you cannot just come with a conclusion and then you said Bowling Green has the lowest cost without specifying the range. It doesn't make sense, right? So you must have the range or the intervals that a specific range is optimal compared to other locations. So that's how you analyze this. And during the our other sessions, where we're going to have some exercises and all that, I'm going to demonstrate how you can also have the same result without even plotting the graph, doing the calculations and identifying the range or the intervals where each location is best compared to other locations, just through the calculations. So this is the graphical interpretation, and you can also mathematically interpret the result of the analysis without needing a graph. I hope that is making sense. If it's not making sense, guys, feel free to ask questions. But anyway, we're going to have some exercises on this because especially this break-even analysis is going to form a great part of the upcoming test. Guys, can you still hear me? Please double check there if you guys still hear me, if you guys are still online or probably I'm offline, I don't know. Ladies and gentlemen, are you guys still there?
Yeah, we hear.
Beautiful stuff. Thank you. Okay, so let's proceed. The next item or the next method that we also going to talk about is what we call the center of gravity. So what is the center of gravity? Basically, we are talking about locating a distribution center, right, from a point whereby the distances, right, are kept at, how can I put it? The distances are quite close to each other in order to minimize the cost, because at the end of the day, transporting materials, right, from the distribution center to the different branches for a company is costly. So identifying a proper, right, location that tends to reduce the different distances between the distribution center and the different branches is quite important. And that's why the center of gravity comes in. So the center of gravity here says that finds the location of distribution center that minimizes distribution cost, right? And considers location of market. You have to identify the location of market where customers are, volume of goods shipped to those markets, right? So you also need to consider the loads, right, that are transported from the distribution center to the market or to the retail, right? So you have to consider that shipping cost always important. So that is why we are talking about the center of gravity, because you want to reduce the cost, which is also reduce the distance, which is related to the different cost implications. So what is going to happen here? The center of gravity is quite straightforward, right? Um, it says that place existing locations on a coordinate grid. So you need to have a grid. It's like still like a plot, but yeah, it's a bit different. It's a grid origin and scale is arbitrary chosen. So you don't need to start from zero, right? Maintain relative distances, calculate X and Y coordinate for the center of gravity, assume cost is directly proportional to distance and volume shipped. Okay, let's just try to see that from these examples here. Oh, before even that, these are the formulas that we're going to use, but don't worry too much. It might look scary and big. It's not really something that you can memorize, but from what I'm going to explain, I believe you'll be able to understand it properly. So here you have a center of gravity, I mean the different locations. Here you have Chicago, with its coordinate. So here we have 30 and 120. So 30 here represent the X coordinate for Chicago, and 120 represent the Y coordinate. Remember, each location must have two coordinates, the X coordinate and the Y coordinate. So the same applies for New York, Pittsburgh, and Atlanta. So now we need to understand that we are talking about the distribution center here. So minimizing the distances. In other words, shipping materials from the distribution center to this location here, Chicago, New York, Pittsburgh. Where can that distribution center be located in order to minimize the distances? Because that is the question that you should ask yourself. From here, where can you put that distribution center? Can we put the distribution center here? Or we can put the distribution center here. But in order for you to guess, in order for you not to guess, that's why we do the calculations in order to get accurate, how do you call it? Result on where the distribution center should be. So going to the origin of the scale here, or here you can start, that one it says arbitrary origin. So you can start with 0. From this side, you must start with 0. The other side, you must start with another number. So it doesn't matter in terms of the origin, just to approximately find the proper location. So everything is represented in this table here. Let's just say it. So the locations that you are looking for or we are evaluating is Chicago with its coordinate, you have Pittsburgh, New York, and Atlanta. And you have also the total number of containers shift, right, from to this location. These are the total number of containers shift to this location here. So now the exercise here or the example is telling us to find the appropriate distribution center that can minimize the cost of shipping these containers to these different locations. So in other words, we will find the center of that distribution center whereby distances are minimized. So in order for you to find the center of gravity, we're going to calculate first the x coordinate, and then after you calculate the y coordinate. So it's straightforward. When you are calculating the x coordinate, the focus is on the x coordinate and the volume. So in other words, here you do not interfere with the y coordinate. Since we are talking about the x coordinate, you must only focus on the x coordinate. For Chicago, you have 30. You have 30 here. 30 multiplied by the number of containers moved to Chicago. So that is 2,000. So that's why you have 30 multiplied by 2,000. Pittsburgh, you have the x coordinate of 90. So 90 multiplied by 1,000. New York, you have 130. 130 multiplied by 1,000. Atlanta, 60 multiplied by 2,000. That's what you have here in the numerator. And in your denominator, you're going to have the sum of the containers shift to this different location. So that you're going to have 2,000 plus 1,000 plus 1,000 plus 2,000. That's what you have in a denominator here. All right. And then once you have everything in order like this, just use your calculator in order to do your calculations. And you'll find out that the x coordinate is 66.7. So this is the x coordinate of the distribution center, the appropriate x coordinate that the distribution center should be. Now, once you are done in the x coordinate, you move to the y coordinate. So in order for you also to come up with the y coordinate, you must only focus on the y coordinate of each of the locations. So here you have Chicago 120. You have to also to multiply that by the 2,000 number of containers shipped. So 120 multiplied by 2,000. Here you have 100 Pittsburgh, 110 multiplied by 1,000. New York, 130 multiplied by 1,000. And Atlanta, 40 multiplied by 2,000. And that is exactly what you have here. And again, in your denominator is the same thing as in the same thing we did in the x coordinate. So you sum up all the volumes here, all the number of containers shipped, not shipped, shipped. Okay, anyway, shipped. So here, you calculate, you just punch everything in your calculator, and that is gonna give us, or give you 93.3. So this is the y coordinate of the distribution center. So now you have this, you have the x coordinate and the y coordinate. Usually in the test, you're not going to plot it or put it on a graph. You just need to calculate this, the x coordinate and the y coordinate based on the questions. You're not going to plot any graph, but for the sake of you having a bigger perspective of how to come up with or how to plot this or to put this on a graph, you can see here, we say the x coordinate by doing the calculation is 66.7. All right, so 66.7. 66.7 should be somewhere here. So that's why if you draw a line going up to pass here, and on the side here, you have the y coordinate of 93.3. So 93.3 is somewhere here. So you draw another line where they're going to meet. That is going to be the center of gravity. And that's why you have this plus sign here to show you the center of gravity, the appropriate center, which is going to minimize the cost of distribution, right? So this is how you come up with a center of gravity. And this is quite good because the company is now able to minimize the cost of transporting goods from this distribution center to Chicago, to New York, to Pittsburgh, and to Atlanta, right? And also based on these calculations, we know that this is accurate, right? So that's how you proceed, or you do an analysis related to the center of gravity for a business. So what you need to understand here is that you need to have the coordinate of the locations, and then you evaluate them in order to come up with the appropriate center of gravity, or the coordinate of the center of gravity. So the next model is what you call the transportation model. So the transportation model is also basically talking about the distance, right, between work centers, right, the distance between different branches of a company, or it could be locally or internationally. So we are going to discuss in terms of reducing the distance, which is also related, which has cost implications. So that's what we're going to discuss under the transportation model. but we're not going to do it today. This will probably form part of a session that you're going to have, like an exercise, where we're going to demonstrate how to deal or how to analyze a transportation problem. And I'm also trying to see if it's possible for me to give you guys an assignment based on this, so that when I'm explaining, I don't even explain too much, and you will discover more stuff while you'll be doing the assignment. But you will see. Yeah. So guys, I think that's what we needed to discuss today. And next time where we're going to meet, we're going to have some exercises in order to understand how to approach a scenario whereby you are asked to use probably the factor rating analysis, the break-even analysis, or the center of gravity model in order to come up with appropriate recommendations. So that is what is going to take place. And in the meantime, also, there will be some tutorials. I think you guys are gonna kickstart with the tutorials next week. So please be prepared for that. If you guys also have suggestions in terms of how the tutorial could be held, you can also let me know, or you can speak to your tutor to see if some of you, if you find out that coming to school on Friday it might be an issue for you guys. So you can probably find another day whereby the venue is also available, and then you can have tutorials, can shift the Friday's tutorial to another day during the week or before Friday, so that on Friday you guys are probably free. All right, guys, any questions before we take the attendance register? All right, so it seems like you don't have questions. So let's quickly take the attendance register before we go, so that we know who attended the session or didn't attend. And we are now forced to be taking this attendance register. Uh, just wanted to stop recording. Let me do this. Can I make this thing big? Let me stop recording, and then we can take the attendance register. Stop recording. Beautiful.